Hi, everybody. So I understand that I'm the last talk in between you and the beer, which is not really a good position to be in. So I'm just going to get right into the talk so that we can get through it so we can all get into drinking our beer. So I'm actually not going to spend a lot of time this afternoon talking about Google Analytics for Firebase. I'm assuming that if you are in this talk and at this conference, you kind of have a general understanding of how analytics works. Like, you're recording these events and these user properties on your device, and then these get sent down into the analytics server, which kind of uses up all that data to generate all of the lovely reports that you see on the Firebase dashboard. And gee, maybe we need to update this because we now have a new dashboard. And while these reports are great and they answer a lot of interesting questions, at some point you're going to run up against the limits of the reports that we're able to generate for you. And you're going to need to basically run some ad hoc queries against this historical data to get very specific questions that are very specific to your app. And that's where BigQuery comes in. BigQuery, as you may know, is a service designed to run very fast queries over very large amounts of data, like, for example, all that analytics data that your app is generating. So the idea is that when all this data gets sent to Google Analytics for Firebase, a copy of it is also sent to BigQuery. And Analytics will still go ahead, use up that data to generate all the reports that you see in the dashboard, but all that raw data sticks around in BigQuery for you to query as much as you want. And so whenever a developer has a question about, hey, how can I get at this obscure little report in Analytics, our answer is usually, oh, just go into BigQuery and you can answer it there. The problem is that you have to use SQL to do it. And I'm guessing probably a lot of you, I certainly am like mobile developer or web developer, and maybe you haven't used a whole lot of SQL since like 2008. And I don't know, back when I did it, I added one join and thought I was a big SQL hacker and put that in my LinkedIn profile. And so I hadn't touched SQL in many years. And when it came to sort of figuring out how to analyze all the Firebase analytics data, it was a little tough at first. So I'm going to show you a few things that I learned when I first tried to analyze my data in BigQuery that made this a whole lot easier. And we're going to start with the data structure, because it's probably not what you're expecting. If you've played around with any of the public data that we have available for BigQuery, like, for instance, here's some sample data from the World Health Organization. All of our sample data generally kind of looks like this, sort of these nice little tables that you might see in any old MySQL database or something with sort of strings and integers and these individual columns all nicely lined up in these rows like this. But it turns out that BigQuery can actually be much more sophisticated than that. These rows in BigQuery don't necessarily have to be single rows of nicely organized tabular data. They're sort of more like this, sort of individual JSON trees, each of which can contain key value pairs or arrays or objects or arrays of objects. And that's important to understand when you're looking at analytics events in BigQuery, because the first thing you're going to assume, and certainly the first thing I assumed, is that every row in BigQuery corresponds to one analytics event. And it turns out that's not the case. You can actually have 2 or 3 different analytics events all in the same row in BigQuery when you're trying to analyze that data, sort of all bundled together for the same user. So to better explain this, let me show you what our actual data schema looks like. So this is basically one row of analytics data in BigQuery. Just memorize this and you're all set. So yes, it's a little complicated at first, but let's get to know it a little better because it's probably not quite as bad as you think. So first we have this user info section, and this contains a few straightforward key value pairs, like sort of the first time the user opened the app and an optional user ID parameter. But then this also contains a number of nested objects, like the device info, or their geographic location, or the traffic source information, what brought them to your app in the first place, and so on. We also store user properties. And as you probably know, since you can store many user properties for the same user in Firebase Analytics, or Google Analytics for Firebase, these are basically stored as an array of objects. Now, these objects contain the name of the user property stored in this key, and then the value. Now, the value itself is an object that contains a couple of properties that, honestly, I almost never use, and then another smaller value object. And this value object contains an int value, float value, double value, and string value entry. And you'll find that in practice, most of these will be null, except for the value that you're actually looking to store. And the reason we sort of have this structure is that for multiple user properties, or as you'll see soon, event properties, we can basically store any type of data in basically the same format, right? And we don't have to kind of change the way this data is stored. And then basically the nice thing about keeping all of this inside an array in user properties is that you'll find that in practice there's not a lot of joins you have to do. Like I don't need to grab some other data from some other table to grab user properties for a specific user and join that up with an event. It's all sort of nicely contained in BigQuery for me. And you'll see that in the demo in a little bit. So then in addition to all this user information, we have some event information. And as I mentioned earlier, events can be an array of 3 or 4 different events all bundled together. And these contain a few straightforward key value pairs, like the name of the event and a timestamp. But then they can also contain an array of event parameters, because you can store multiple event parameters for any particular event. And similar to user properties, these parameters are objects that contain the name of the event parameter, as well as a value, which is int value, float value, double value, and so on. And so this holds true for every event parameter for that specific event. And then this whole structure holds true for every event within the event array. And so that's what you get here. And so that's basically our entire data structure. So I know it kind of looks like a lot, but once you kind of get to know it, it's not so bad. It's just big. So with that under our belt, I want to take a look at our Bingo Blast game. This is a game that's really out there in the App Store. Maybe you've seen us use it in demos in the past, like this morning. And this, because it's an actual, app that's out there, we have some nice data that we can query in BigQuery. And it has this round completed event. This is an event that happens at the end of every round. And this event contains a number of parameters associated with it, including the overall score, what type of game it was it solo or social, and so on, along with sort of a number of other events or event properties. And then we also store a number of different user properties, including is the user signed in, have they spent money in the game in the past, and what's their, how many experience points they have. That's that thing we have labeled as XP, which is a good indicator of how long your user has been using this app. So with this in mind, there are a number of questions that I want to get answered that I can't necessarily get answered from the Firebase console. And so let's take a look at how we can use BigQuery to maybe answer some of these. I'm going to start with this first one, which is what is the average and the standard deviation of our score in a typical bingo round? Basically, how can we get at some more data about an event parameter? So with that, I'm going to jump over to the demo. I think my laptop's asleep, so let me wake up my laptop. All right. So we can switch over. Can you all read that? Should I make it a little bigger? I'm seeing a couple thumbs up. All right, if just shout out, too small if you can't read it. So this is basically what you would get if you were to just sort of get any data from an app events table. This is the analytics data that you'll get from BigQuery. So you'll see, here we have a couple of user properties. Some stuff associated with our user. Here are user properties. Here you can see, it's essentially an array. We have all these different user properties, and we have the key, and then the value, string value, and int value, and so on. Scroll over here, we can see some of this nested data, including here's where the user is located when they were using this app, what platform they were on. Scroll over a little bit more. Here we can see our events. So it looks like we have a session start and a tutorial begin event sort of bundled together in the same row in Firebase Analytics. So I'm interested in the round completed events. So let's start by selecting just our event dim. So I'm going to run this query. And this is basically, here's one row in our table, which basically just has, in this case, it just happens to have one event. It's our round completed event. And if I look down here, I can see, oh, look, there's that score parameter that I'm going to be interested in analyzing. So let's start by just getting our round completed events. And so what I'm going to do is I'm going to say, let's select event dim from this thing, where event dim.name equals round completed. And I'll run this query, and I will get this very clear error that says, oh, you can't access field name on a value with type array, struct, string, nams, array, struct, array, whatever. So what does that mean? Good question. Let's go back to the slides. So the issue here is that event dim is an array, right? It's an array of 1 to 5 different events all bundled together. And while it might contain objects that have a name property, event dim itself doesn't have a name property, right? It's just an array. So how do we get at this data? Well, we're going to get to our first tip, which is using unnest to basically sort of extract any data that we have stored in an array. So let's start with a simpler example. Let's say I have a starships table, right? And I want to basically find every starship that has a crew member named Zoe. Well, this statement does not work, right? I cannot select starships where crew equals Zoe because crew does not equal Zoe. Crew equals an array. And yes, that array might contain a string named Zoe, but crew equals Zoe does not work. So instead what I have to do is I'm going to say, let's select from starships, cross-join unnest crew as crew member. And so what this crazy statement does is it says, OK, let's take all the elements of that crew array and move them into their own individual entries in a column we're going to call crew member. Now, as we do that, we're also going to duplicate our original row in the database as many times as needed to basically sort of make sure we've sort of filled out all of our crew members. Well, once we've done that, and in practice, we tend to just replace that cross-join with a comma, because it's a lot nicer looking. Well, now we can query this, right? Now it's very easy to say, let's select from this table where crew member equals Zoe. And sure enough, we can find all of our starships that have a crew member named Zoe. And so that's basically what we're going to do with our event array. So here we have this event dim that might contain a few events in it. I'm going to say, let's select from app events, unnest event dim as event. And what that's going to do is that's going to take these individual objects and move them into their own column called event. We'll sort of duplicate this row as many times as needed so that basically we have each event now in its own row, in its own column. And then once we do that, we can basically query the individual record. Now we can say, all right, now let's look for the round completed events, and we'll just get those. And I find that it's a little confusing sometimes to see sort of your original event dim array right next to the event you're actually interested in your results. So you'll find in practice, people don't do select star. They might just say, you know what, let's select event. And so that will get you just the event you need. So let's take a look at doing that in my demo. So we're going to jump back to BigQuery here. And so now I'm going to say, all right, so we're going to select from this unnest event dim as event. And so now what I'm going to do is I'm going to select just the event, and I'm going to say where event.name equals round completed. And so now if I were to run this, you can see that I now have just the individual round completed events, each one in its own row in this table, which is great. So now to get at the score parameter, well, gee, it kind of looks like our event params are also being stored in an array. So it's very easy to get at that as well. So what I'm going to do is let's select our event. We'll just get our event.name. And what I'll do is I'll unnest event.params as param. And so we'll select that and param. And I forgot to add a comma. So I run this, and now I can see I have my event with every individual parameter in its own row in the database, or in my results table. And so once I've done that, it's very easy to get at just the ones that have the score. So I'm going to say where event name is round completed and param.key equals score. And I run this, and now you can see I've got my parameter, and I've got my param.value object that has string value, int value, float value, and double value. And well, now getting the results is actually pretty easy. I'm just going to go up to the top here. I'm going to ask for param.value.int value as score. Run that, and now I have my event and my event parameter nicely organized in its own little table. And now I can do stuff with it, right? And so let's get our average of this thing, and we'll call that average score, right? And we'll copy that, paste this. Whoops. Let's actually spell average, right? And we'll get our standard deviation as our standard deviation score. Run this thing. And sure enough, we get our score and our standard deviation. And yes, apparently it is normal to have a standard deviation that's greater than your average. It just happens, I guess, in games like bingo where you can end up with a very wide range of scores. So there you go. So let's jump back to the slides. And basically, it looks like we now have our first question answered. So we now know the average and standard deviation of a score in a bingo round, and in general, how to query specific event parameters. So let's look at this next one. How does our score correlate with a player's experience level? So what we're doing is we're trying to find a correlation between an event parameter and a user property. So let's jump back into our demo and see how we can get that one going. So let's just jump over to, this is basically the query we were at a little while ago. We've got the name of our event, and we've got our value, our score value. And so I need to grab user properties as well. And as you recall, user properties are also being stored as an array. And so just the same way we can extract events and event parameters, it's very easy to unnest our user dim, come on, autocomplete. Hey, look at that, as user prop. And so let's select this, and we'll select our user prop. And what this is going to do is basically now for this round completed event, you can see I now have expanded it out to have one row for every user property. Right? Here's our API version, how many power-ups they have, when they first opened it, and so on and so forth. And somewhere here, like on row 11, here's the XP. So again, sort of the same way we're able to filter for our specific event parameter, it's very easy to then say and userprop.key equals XP. And sure enough, we're going to end up with a table where we've got our name, our score, and then just our user property all nicely arranged in one table. And then extracting the value of our user property is pretty easy. You might be wondering, hey, why is this being stored as a string value? And the answer is that basically in the analytics client API in the client library, basically all your user properties are stored as strings. But turning this into an integer is pretty easy. Let's just here we'll cast our user prop dot value dot string value. Man, I can't type today. As int64, and we'll call that XP. And we'll run this. And here's our score and our XP all nicely arranged in a table for us. And then I could probably kind of muck with this select statement to get the correlation between these two by sort of doing this. But I actually don't want to do that because I want to show you one other technique that is very common in when you sort of get to more complex BigQuery queries. So let's jump back to the slides. And that is using subqueries to make your life easier. So you might have noticed sort of up till now we've had sort of this giant BigQuery table that's got all this stuff, and then we run a select statement on it, and then we end up with sort of this nice results table. And you might be thinking, hey, that table kind of looks like a SQL table too. I wonder if I could query that as well. And so you can, basically using subqueries. And the way this works is generally you're going to make a select statement the way you would any other. It's just that instead of specifying a specific table, you're going to use your results from another query. And that basically sort of allows you to sort of, basically, do this as many times as you'd like. If you're used to other SQL databases, I think this is commonly done as a view. I've noticed in BigQuery land, people seem to do subqueries a lot more. I'm not quite sure why. Maybe it's just sort of what happened, but it might also be that I think in BigQuery land, doing this is actually fairly efficient. And so I think that's why you see a lot of developers who like doing this. But it also means if you check out any of our documentation, you might start to come across queries like this. And you're like, what is all this? It's a giant mess. But actually, if you start to notice that it's subqueries, it's not really that bad. All you do is start by just looking at sort of the innermost query. And once you just focus on this, you realize, oh, this actually isn't so bad. I understand this, and I understand what results it's going to give me. And then once you understand that, and in most cases you can actually just cut and paste this innermost query and run it yourself, then it's easier to understand sort of the next outermost query, what this does. Can you see those highlights? You can barely see those highlights. I'll make them darker next time. And then, once you understand how that next outermost query goes, well, then you can kind of understand the next most outermost query and so on and so forth. So next time you come across a giant statement like this, don't freak out. Realize that they're probably using subqueries and that if you break it into pieces, it's actually pretty easy to understand. So let's go back to my demo, and I'll kind of show you that. So what I'm going to do here is I've got sort of my results table, or I've got score and XP, so it's very easy to select the correlation between score and XP from this thing. We'll run this, and if everything goes well, I find out that I have a slightly positive correlation between score and the player's experience, which you kind of expect in a game like Bingo, which is mostly luck, but there's a little bit of skill. So let's go back to the slides, because I think we finished up task 2. Let's see. Yes, all right, we got a check mark. All right. So let's look at this next one, which is, can we break out our score by our game type? This sounds kind of similar to the last one, but this is a little trickier, because what we want to do is break down one event parameter by essentially another event parameter. And I'll kind of show you why this is tricky when I go back into the demo. All right, so let's run this query here. Here I've got basically sort of my round completed event, and I've unnested all my event parameters. Now, type of game, this is the event we're interested in grouping our score by. We want to see, there's 2 types of games, solo and social. How does our average score change if we break it up by type of game? And yeah, somewhere over here is score. And the thing you've probably noticed is that XP and score are in entirely different rows in the database. And unlike when we sort of unnested our event parameter and our user property, these are on different rows, and it's kind of hard to get them together. I think the way I did this at one point was to add on the app instance ID and the event timestamp, which lets you essentially figure out which event parameters belong to the same event, and then group them and do all sorts of subqueries on them. But I don't do that anymore, because I actually found out that there's a much easier way of handling this. So let's jump back to the slides, and I'll show you real quick, which is our select from unnest tip. So this is basically sort of a combination of our first 2 tips. So let's imagine we're selecting our event name from our app events where we've unnested our event dim, right? So far this should probably look familiar. So let's look at this next line. Select value from unnest event params where key equals score as score. So what does that mean? Well, basically, this from unnest event params, what this basically does is this creates sort of, you can think of it like a temporary table, where we take our parameters in that event and sort of expand them out. And then we say, OK, well, let's just grab where key equals score. And so now we just have one entry from our parameters array. And then what we can do is select the value of that, and that will be in a new object or a new column in our database called score. And that works for basically every row in our table. And the nice thing about doing this is I can basically do this multiple times for multiple event parameters. So I can run this whole line again. Select value from unnest event params where key equals type of game. And I can then take just the type of game entry from parameters, and that will then become its own entry in a new column. So this is nice because I can then do these different event parameters side by side. I think it's also probably a bit more performant because you don't have the x times y times z number of rows that you would get if you do too many unnest statements. So this tends to be sort of a nice way of doing it if you can. So and yes, this goes out to all different types of games. And then there's a keynote error. So we'll just jump to the next slide. All right, so let's go back to the demo, and I'll show you that in action. So let's select our event name, and instead of unnesting our event params and doing all of that, I'm going to select our event name, and I'm going to select value from unnest event.params, where key equals score. And when I run this, why are you giving me an error? What's up? Oh, because I need a comma. There we go. By the way, this little validator, super helpful. If you turn this on, it'll tell you before you run the query what errors it sees. It's kind of nice. Also helpful when you're doing live demos. So what we have here now is we have our event name still, and then we have this unnested event params object, which, as you can see, has our string value and our int value and our float value and our double value. And as we know, all these are going to be null except for the int value. And so now I'm going to do the same thing. Let's copy and paste this thing. And we're going to get not just score, but type of game. And when I run this, you'll now see I have these two value objects side by side, right? Here's my int value for the score, and then here's the string value for the type of game. And then, let's just make sure we get the relevant values. So let's select value.intValue, and that will be as score. And we'll get our value.stringValue, and that will be as type of game. And I'll run this. And if all has gone well, there we go. We have our score and type of game all next to each other in one nice little table. Oh, there's some social games. And then, basically being able to break this down by what game type is as simple as doing a subquery. So let's, we'll select our average score and our max type of game from this table, and we will group by type of game. And I'll run this, and if all's gone well, sure enough, it looks like people that play our social game earn like 4,000, 3,400 points on average more than people who play our solo game. And that's information maybe we want to bring back to our game designer, but maybe they like that. Maybe they want more people to play the social game. So with that, let's go back to the slides. So that basically answers our third question of, can we break out our score by game type? Yes, we can. Good thing I put that up there. All right, let's look at the next two questions. So these next two are basically making use of techniques we've already learned. So I'm not going to show you, the demo, but let's show you how we would answer these in the slide. First, can I filter results for a range of user property values? So basically what we want to do is, in the Firebase console, you can filter results by a specific user property value, language equals English. What if you wanted multiple user property values? Language equals English, German, Dutch, what have you. So basically, we can do that. But this is essentially the same query as before. Here I'm selecting, the score, the event name, and it looks like I'm grabbing the, here I'm looking at the player's experience points as well, right? And so this should look like a fairly familiar query, but now just in my subquery, all I have to do is say, hey, you know what, let's just look at these results for when our XP is in between 1,500 and 15,000 and 25,000, right? And that's it. That's all you have to do once you sort of learn to deal with looking at user properties and events this way. And we end up with a result that I think is right. I actually don't know, but sounds right to me. So that answers the fourth question. The fifth question, can I filter results by two different user properties at once? In other words, if you were to go to the Firebase console, you could filter your results by are they a spender or not, and do they have a lot of power-ups or not? But what if you wanted to filter by both of those at once? Currently not something you can do in the Firebase console, but it is something you can do in BigQuery. And basically we do this just by sort of making liberal use of the select from unnest method that I talked about just a few slides ago. So here you can see I'm selecting where, the highlight, sorry. If you can see the highlight there, I'm highlighting that second line where I'm grabbing the score parameter, right, the int value from the score. And then I'm also grabbing, are they a spender or not? And then, how many power-ups do they have, both of which are being stored as a user property. And I end up with results that look something like this. I can see their score, are they a spender? How many power-ups do they have? And then once I have that, it's fairly easy to do a subquery based on this. This case statement at the top, all this is really saying is, since basically our number of powers is kind of this giant range, I'm just saying, hey, let's break it into two values. Few power-ups if you don't have a lot, and many power-ups if you do have a lot. And then by grouping by, are they a spender and, how many power-ups do they have, I'm able to get a result that looks like this. And I can then say, okay, well, it looks like spending money in my app doesn't necessarily get you a better score, but very clearly it looks like having a lot of power-ups does. So that's good to know. And that basically answers our fifth question. All right, so this sixth question, what's causing our users to spend virtual currency? So this is like a super interesting one. So let's take a look at it. So I'm going to jump into this query. And this here is my spend virtual currency event. And this is something that, as a game designer, I'd be super interested in. Because this is probably where I'm making money. So, or as a game designer that maybe wants to make a profit, this is something I'd be interested in, right? Like this is where my user's spending the virtual currency. Maybe after some point they want to buy more gems or what have you in the game. So I want to find out what's sort of leading up to this. So let's take a look here. I'm going to start by just selecting all our events, and we'll look at our event.name. And then I'm going to look at two other things. First, I'm going to look at app info app instance ID, and we'll call that as app instance. So app instance ID, this gets assigned for you automatically by analytics, and it's essentially a unique number assigned to any instance of your app that is happening on any specific device. And it's sort of a good way of basically grouping all your events together that you know are happening for one user on their device. You know, if I play Bingo Blast on my iPhone, all those events will have the same app instance ID. But none of you will have that app instance ID because you're all different people with different devices. So I'm going to grab that, and I'm also going to grab the timestamp. And then we will order by these. So we'll order by, I'm just going to copy and paste, app instance, and event timestamp. And when I run this, what you're going to see is that I basically kind of have like a nice little journey of my user as they sort of work their way through the app. So I can see for this particular app instance ID, this particular user, like they initialized the API, they logged in, they spun the slots, they spent virtual currency, and so on and so forth, until we get to sort of row 12, it looks like. And then on row 13, we have a different user, right? The different app instance ID. And so we can see this user, they opened the app for the first time, they triggered a user engagement call, they initialized the API, and so on and so forth. And kind of just by browsing through all of these, you might be able to get sort of a nice qualitative sense of how our users are interacting with our app. And that's kind of neat, right? But, we want data. So this isn't good enough. We need to find a way to kind of group these. And more importantly, we kind of want to find out we want to find a way within the same row of our table to kind of look at any event and say, hey, here's what's going to happen next. And so to do that, we basically need sort of a better way of looking ahead in the table. And for that, I'm going to use one more technique. Let's jump over to the slides here, called using lead to peek ahead. So here's how this works. Imagine I have this table where I've got name and age, right? Hopefully, by now, this should not confuse you. Nice little table. But I'm going to add this line, lead name 1 over order by age as next oldest. What does that mean? This means, let's pretend we have a copy of this table, okay? And this order by age means, let's sort this table by age. And then this lead name 1 basically says, all right, for every row in the table, let's find where it would be in this imaginary table, and let's peek ahead one row. And then we're going to grab the name value. We're going to grab, in this case, summer. And that will be stored in our original table as next oldest. And we do that for every row in our table. And you'll notice here, Rick's next oldest is null because he's the oldest person in our table. But this essentially allows you to peek ahead in your result set. And so let's show you how we would do that in the demo. All right, so I'm going to keep everything I have before, but now I am going to lead event name 1 over order by, and we're going to grab our app instance ID. Unfortunately, I can't use the little as. I have to use the full thing. And our event timestamp micros. And when I run this, what you're going to see is now I have essentially sort of the next event that happened for this thing. So initialized API, user logged in, slot spun, spend virtual currency, and so on and so forth. And this works fine right up until we get to row 12, where it says, the next thing that happened after user engagement is first open. And that's because it's basically just sort of looking at the next row in this sorted table. So the way we fix that is we say, OK, let's partition by app instance ID, which basically says, let's take that imaginary table and break it up into lots of mini tables based on their app instance ID, but we'll still order by the timestamp. So when I run this, you're going to see I basically get the exact same results as before, but if I jump over to row 12, you'll see the next thing that happens after user engagement is null, because we've sort of reached the end of that little mini partition table. And so now, I'm going to say, let's do this one more time. Here I'm going to let's move event name down here. And I'm going to call this step 0 because we're engineers and we're 0-based. And this will be S1. And let's do it one more time. This will be S2. And when we run this, we're going to get nice little triplets of events that our users sort of went through in our app. And then to say, well, OK, let's just find the ones that end with them spending virtual currency. Well, gosh, we know how to do that. That's a subquery. So let's select S0, S1, and S2 from this whole thing, where S2 equals spend virtual currency. So I'm going to run this. And if all's gone well, sure enough, we get just the triplets of events that end with them spending virtual currency. And then once I've done that, it's super easy to group them and order them and stuff. So let's, here we'll group by S0, S1, and S2. We'll add an account as count. And we will order by count descending. And when I run this, sure enough, I can see the most common triplet of events that ended with our user spending virtual currency, right? And I can start to dig into this more if I wanted. OK, it looks like a round completed event. What actually happened there? Did they win? Did they lose? What's happening that's causing them to say, yeah, I think I'll spend some virtual currency once that round is over, right? So yeah, let's go back to the slides here, because I think we basically answered that question. And by the way, you can basically use essentially this very same technique for the screen view event that analytics has started adding. My sample data is a little too old, but I think a few months ago, maybe earlier than that, we started adding this screen view event that sort of automatically records what screen your user is on. And so basically, by sort of running the same kind of thing, you can kind of get a sense of how your user is progressing throughout your app, and you can kind of get a sense of what paths are they taking more often than others. And so that basically answers our second to last question. Now, I'm running very low on time, so I'm going to quickly breeze through this last one, which is what percentage of our users who start the tutorial finish it within 4 hours? So this is basically a closed funnel. Right now in the Firebase console, you have an open funnel, but I want a closed funnel of let's see how many users who started the tutorial and then finished it we encounter. And then, just to be extra fancy, let's add a time limit onto that. So it's got to happen within 4 hours. So, we're not going back to the demo. All right, so we'll start by just taking a look at these two events that I want to build a funnel out of, like our tutorial begin and our tutorial complete. And we have them here. All right, not very exciting yet. It'll get better. Now I'm going to use the same trick I added before, where I'm basically going to add the app instance ID and the event time, get the timestamp, and we'll order by those. And so now we kind of have individual user journeys focusing on just these two events. And we can start to see, OK, here's a couple of users who started the tutorial and then completed the tutorial. Now I'm basically going to add my own little two special columns called funnel start time and funnel end time. So we'll see the funnel start time event if they began the tutorial and the funnel end time if they didn't. And I could count these up, and that would essentially get me an open funnel, right? This would get me how many start events I had, how many end events I had. But for a closed funnel, we want to say how many end events happened after the start event. And for that, we need to peek ahead in the database. And oh my gosh, how do we peek ahead in the database? Oh, that's right, I remember. We're going to bring back lead. So we're going to select our funnel start time, and then we're going to lead basically sort of one row ahead in our database to say, let's grab the end time if it exists. Partition by app instance ID, order by event time. And what we end up with is our start time, and if there was an event time right after it, get those bundled together in the same row in the database. And then, we actually can count these up, right? I can basically just say, all right, if they're not null, we'll count them up. And that gives us the number of basically funnel begin events and funnel end events. And this is basically how you would calculate a closed funnel. But since we wanted to be extra fancy and add in a little time restraint to it, what I'm going to do is I'm going to just look, instead of is the funnel end time not null, is this funnel end time less than 4 hours after the funnel start time? And if so, we'll count it up. And it turns out in this case, the results were the same because it doesn't take 4 hours to complete a tutorial. But if I decrease this to like 1 hour or 2 hours, you do start to see a different value. And I guess our last tip, which I didn't have time to put in a separate slide, is you can also do this across multiple tables. So right now I've been doing all this against app events, 2016 0606. But if I replace that with a little asterisk, a little wildcard, then I can add this very special parameter, table suffix between, and then I can basically specify any two dates that I want. And that would give me this same result, but now I'm looking at it over the course of 7 days. And with that, I believe we have answered our last question. So if you've been watching all this and you're like, wait, I've been trying to take pictures of all that code and you went too fast and everything, don't worry. So we have a short link and we have a QR code, and I promise I will not be rickrolling you. Just take a picture of this. I'll wait for everyone to kind of... Oh yeah, should I move? I don't want to block the QR code. That would be awkward. All right, I think everyone's got it. And if not, it's also going to be probably in the live stream video and all of that. And so with that, I know I am out of time. Q&A will not be in the Ask Firebase Lounge because right after this, we're having the party. So if you have questions, find me and buy me a drink, or I guess drinks are free. Give me a drink. And as the course of the night goes on, my answers will get worse and worse. And with that, I'm going to say thank you very much. I'm going to bring Puff back on stage.